Welcome back, everybody. Today's topic 1.1.3. How can I describe a graph? So, what does it mean to create multiple representations of a graph? So, you guys, that's pretty much what you guys are going to be doing today. So, in previous lessons, you've observed like the graphs of linear functions, the graphs of exponential functions, or maybe some other type of functions, like, for example, parabolas, which we'll be looking on later on. So, in today's lesson, you will pretty much investigate multiple representations of various functions. And when I say multiple representations of functions, we have pretty much four different ways of them. One of them is a graph. So one of them's a graph. You guys are familiar with that one already. The other one's a table. The other way is an equation. And then the last way would be pretty much like a situation. So as we're working throughout the course, you guys will notice that all of these will always relate back to each other. And later on, when you guys are working on IM2 and IM3, it's pretty much the same thing. You guys are always going to be looking at different representations of functions. So make sure you guys have your notebook out, copy today's learning target. Make sure you also copy the lesson title. So the learning target for today, students will create multiple representations of four functions and examine the growth patterns and characteristics of the graphs of each. So let's look at the first one. So tile pattern number one, I'm going to give you guys options to do these. So the first option is you can print out the PDF that I've attached to the assignment. The other one is you can use the online tool and keep notes on your notebook as well. You can also use the PDF and the online tools. Whatever you guys want to do is up to you. So on the first tile pattern number one, so pretty much you guys are going to be doing the same thing for all four. First, I want you guys to study the pattern of tiles for pattern one, complete figure 4 on the resource page or on your own notebook, complete the table, graph, and equation for tile pattern 1 on the resource page, again, or in your notebook. Describe how the number of tiles grows from figure to figure. Describe the graph of the function. And when you guys are describing the graph of the function, consider the following things. Like, what is the general shape of the graph? Is it a straight line? Is it a curve? From left to right, is it increasing or decreasing? So is the graph going up or is it going down? Or is it going up to a certain value and then it stops and then from there on it goes down? If you drew a line or a curve through the points and extended the graph in both directions, what would the x and the y-intercepts be, if possible? So the x and the y-intercepts, those are pretty much where does it cross the x and the y-axis, all right? That's what a y or x-intercept is. Where does it cross the x or the y-axis? And are there any values of x or y which are not possible for the function? So here we're looking for values like if you divide by 0, that is undefined. So that is a value that we cannot use pretty much, all right? So let's look at tile pattern number 1. So one of the things that I suggest you guys do is, first of all, start looking at how the pattern grows. So if you guys notice here, like what I like to do is label like color in the ones that are always there, the ones that I started with, right? So I know those are 3. So how did it grow from one shape to the next? How many did I have to add? So I had the 3 original. All right. So and then I added 5 more. Okay. So here on my table, what I can do is like the figure 0, which is right here, is our first one. So I have 3 tiles in the first one. In the second one, I have 3, and then I added 5 more. So that's a total of 8 tiles. So same thing I want to do for the next part. These are the ones that I had from before, right? Okay. And then again, how much did I add? So 1, 2, 3, 4, 5. So that means that I have a total of 8 plus 5, which gives me now 13. And then moving on to figure 3. So again, from the previous one, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. So those are from the previous shape that we had. and then we add it again. 1, 2, 3, 4, 5. Okay. So that means that our next one will have a total of 18 tiles. So now that we are able to recognize how the pattern is growing, right? Plus 5 each time. Therefore, I can determine how many we'll have in figure 4. So in this case, I know that I had 18 from the previous one. So let's draw those in there. So we had 18. So I'll just copy the shape exactly how it is. So that's 2. And then 3, 6, 7. So 3, 6, 7. Oops. All right. And then the ones in the middle. So that's a total like that. All right. So here, these are the original from the previous shape. And again, we're going to add 5 more. So I'm going to put 2 more on top right here, 2 more at the bottom, and then 1 more on the edge right here, because that's how the pattern's been growing. So now I have a total of 18 plus 5, which is 23. And then if this pattern continues, that means that the next shape will have a total of 28. And now that you guys have completed the table, we can start looking at the graph. So using the table and the graph, using the table, we can create the graph. So here we're going to be looking at, all right, so our figure 0 has 3. So we go figure 0, right? That's the bottom one. So 1, 2, 3, that's our first point right there. Figure 1 has 8, so go all the way up to 8. It should be about right there. The next one has 13, so 2, 13, 10, 11, 12, 13. The next one has 18, so 3 and 18 is about right there. 4 and 23, so 4 and 23, so that's 20, 21, 22, 23. And then the last figure has 28, so that will be the last figure right there. And then from here we can start, we have the table, we have the graph, we have the tile pattern, and then we'll think about the equation right now, right? So first part, it says we've done that, complete the table, graph, and equation. So to complete the equation, if you guys notice, this is pretty much, it's a straight line. So we're going up by a rate of 5 each time. And then my starting value, or my figure 0, is 3. So the equation of this is, we can say it's y, which is a number of tiles, equals, right? This is y and this is x, equals 5 times the figure number plus the initial, which is 3. All right, so we have that. We did that already. Describe the number of tiles and how it grows. So for part C, we can say that the number of tiles grows or increases by 5 each time. 5 each time. All right. And then what is the general shape of the graph? It's a straight line. So it's a straight line. We can see that. All right. Is it increasing or decreasing? Sorry, that goes on top. Straight line. Is it increasing or decreasing from left to right? We can say it's increasing, right? It's going up, increasing. And we can see it on the tiles too. It keeps going up by 5. If you drew a line or curve through the points, both directions, what would the x and the y-intercepts be? Well, we can see that the y-intercept, which is where it crosses the y-axis, right? This is the y-axis. This is the x-axis technically. So we know that the y-intercept would be 0, 3. And remember, this is always a point. If we were to continue to extend this, I don't know, maybe I would say it would cross around 2 or -1. So the x-intercept, it's not precise, but I can say it's close to -1 comma 0. And then, are there any values of x or y which are not possible in the function? So here we can consider either there's no negative numbers because you can't get negative tiles. That's probably one of the numbers that you guys can get. But everything else is fine because the line is continuous. So there are, we can say probably just negative numbers. Negative numbers. And that's pretty much tile pattern number 1.